My name is Wilson.
My name is Pranav, and this is our Java game. The goal of my game is to teach basic 1 and 2-dimensional kinematic motion to give high schoolers who are about to take physics, interested in physics, or are taking physics a strong foundation in these basic concepts, so that as they move on in physics, they will be able to solve problems easier and have greater understanding. The goal of the game is to get all the questions right within both of the levels. Now I'd like to explain game mechanics. I'm going to start off with how to play. How to play highlights how to play the game, the rules of the game, goals of the game, and feedback given if the user loses. It also provides the order in which the user should play the game. For example, it shows the learn panel first, then the practice panel second, then the game itself third. An example of a rule that is shown in the how to play panel is this rule. Once you lose the minigame or run out of time, you go back to a physics question, which is a key rule that makes sure that the user focuses on physics and not just playing the minigames. A goal shown is stated here. The goal of the panel is to get the right answer, which will take you to the next panel, which is a minigame. Feedback is shown in the form of an image with a solution to the problem. There is an explanation for each image, so the user knows what they're looking at. Next, the Learn panel. In the Learn panel, 3 equations are shown. The equation is broken up into different parts to explain it to the user, and there is a sentence or a paragraph explaining the equation itself. Back takes you back to the home screen. In Practice panel, the equations are practiced. There is also a visual representation of each equation at work. For example, if I enter 10 here and 10 here, the animation that played in the center of the screen is a representation of the object's motion, with these 2 variables representing the object's motion. Now onto the game itself. Within the game, there are 2 levels. This was a mentor suggestion by Mr. Lorden because he said that it would be easier for the user to focus on what they wanted to practice if 1-dimensional and 2-dimensional kinematics were split up. Let me play 1-dimensional kinematics. Within 1-dimensional kinematics, there are a series of problems like this. The score will increase with each correct problem. Let's see. The answer to this seems to be 18. Now I am rewarded with a minigame. The instructions for said minigame are within the How to Play panel. If I happen to lose the minigame, or I go over the limit of 30 seconds, I'm taken to the next problem. I think this answer is 10. Now I'm taken to a different minigame to provide variety for the user. We found that one minigame was just too boring, but 2 minigames provided enough variety so that the user would be engaged and get through all the problems. Oh no, I lost the minigame. I do not know the answer to this problem, but I'm gonna guess. Oh no, I lost. However, the solution is provided right here, so I can learn from my mistakes and do better next time. Another piece of advice we got from our mentor is the enter your answer right here. Our mentor said that the user might forget what they're supposed to enter into the text field, so that enter your answer text next to the text field is a very good idea. If the user wins a level, the You Win panel is displayed to congratulate them on their success. The flow of the code starts at the Start panel. It then moves to the How to Play panel, Learn panel, Level Selector, and Practice panel. Within the How to Play panel, Learn panel, and Practice panel, there are multiple panels with images on them to explain something to the user. Within the Level Selector itself, it can point to 1-dimensional or 2-dimensional kinematics panels. Each of these point to the Alien Invader minigame or mini panel on event of a correct answer. If there's a wrong answer, they will point to the wrong panel. And if the user wins the game, then they will point to the win panel.
Array of strings is used in the 1 and 2-dimensional kinematic panels to store the answers to the questions. As you can see, each index number points to a string answer value. Here, we use a file to contain our 1D kinematics questions. In the try-catch block, the scanner to read in the input from the file is initialized. And in the while loop, each line from the file is read into the question array. One example of data type conversion we use in our game is the use of integer dot to string. Integer dot to string accepts the integer as a parameter and returns the string value. It essentially converts an integer into a string. We use it in our game when we convert the score from an integer to a string to display it. One place where control structures are used is where we use a control structure to determine the image displayed to the user. The image is displayed based on the problem number. The control structure checks with the condition that the problem number matches up and displays the corresponding image. As you can see, our control structure is broken up into the blocks of if statements so that the code is easy to read and is organized well. A specific GUI event that we would like to refer to is when we use a key listener to detect input from the keyboard to move the alien in the Alien Invader minigame. The listener used is key listener, and specifically, we process the key inputs in the key listener methods. Then, a variable is changed within the key listener method, which changes the state of the GUI by updating the position of the spaceship. Specifically, to update the GUI itself, the paint components method is called using repaint as soon as the variable is updated.
Thanks for listening. I hope you enjoy our game.